faults and the failures due to the interaction is going to be very difficult for the testers. When it comes to the time, you need to remember about two things. One is instant, another one is duration. So port device interacts with a physical way, but when it comes to the data, it interacts in a logical way. Hello everyone, I welcome all of you to the very interesting session, and it's going to be very important chapter also. What is that chapter, sir? Yes, it's nothing but interaction testing. So guys, what exactly that I will be studying in this chapter is what I would like to tell you all with the agenda. So guys, in the agenda, in this session, I will be discussing the first topic, that is going to be the context of interaction. So what exactly the interaction is all about, how exactly the problem will be created for the testers, and how exactly we will overcome from that is what I will be discussing with respect to the context of interaction. Yes. Then after that, a very important part of this chapter, that's going to be the taxonomy of interaction. When I'm discussing the taxonomy of interaction, you will have mainly 4 important points. So in that, I will be discussing in this session, that is going to be the first 2 points. So that's what you need to understand. In the next session, I will be covering the rest of the topic of this chapter, is what you need to remember. And I promise all of you, please watch the complete video. You will get a lot of knowledge with respect to the interaction testing. Let's check what is that I have in this session. Guys, interaction testing. When I say interaction testing, the first and the foremost thing that you need to remember is, so please understand, faults and failures due to the interactions are the headache for the testers. So that's a major thing that you need to remember. Faults and the failures due to the interaction is going to be very difficult for the testers. So that's going to be very, very important that you need to understand. Sir, why it is going to be difficult? So please understand the second point. It makes them difficult to recognize even after a rigorous testing. So I will not be able to identify the faults and the failures even after a rigorous testing is what you need to understand. So that's going to be the next important point. So what are the next that I have? These are the defaults once that remains in a system even after you perform the testing. Even if you perform a lot of testings, you will not be able to remove from the system is what you need to understand. That's why it's going to be very difficult for the testers to handle this faults and failures. One more important point. Now it is a fault in my system, but later on that fault will get converted as a failure once I give it to the customer. So that's going to be one more headache for me. So this is what that I need to remember before I start my interaction testing. So guys, so let's understand how exactly I will have the interaction testing. So guys, before that, so we need to understand the context of interaction. When it comes to the context of interaction, so you all know that I have some of the 5 important constructs which mainly dependent on, or which we are dependent on, so for the complete testing. So what exactly that 5 different constructs, especially that 5 different constructs are, so guys, first one is data, the second one is event, thread, action and ports. This is going to be the 5 different constructs that I have here. Sir, do you think that all your systems revolve around these 5 different constructs? Yes, I feel that something is missing. So what exactly that? Yes, that is going to be the location. So guys, can I consider the location as the 6th construct? Yes, I feel that I should also add this location to the construct part. So yes, in total, I will conclude by saying that I should have 6 basic constructs. This, when it comes to the location, sir, you are directly going to the location. So you did not discuss about data, event, thread, actions and the ports. Yes, I have discussed this in detail in the concept of system testing. I want all of you to please go back and check what exactly I have discussed about this 5 different constructs. Yes, it's time for me to discuss something about location. When it comes to the location, my dear students, it's very important that you need to remember. So I will have two important things. Okay, so that's going to be the first one is time, another one is position. When it comes to the time, you need to remember about two important things. What exactly that, sir? One is instant, another one is duration. I repeat, when it comes to the time, you need to remember about two things. One is instant, another one is duration. Sir, what exactly this instant and what exactly this duration is all about? Yes, I will speak about it. Before that, I have one more important point. Information about the location is mandated as a requirement. That requirement is forced in the implementation choice. This is very important. Please understand. Information about the location is very, very important. That's why we have this location has the sixth construct. If they ask you, please mention the basic constructs, you should be able to write all this construct, including the location. You should be able to write. And also you should mention the importance of location and the different parts that is missing in the location is what you need to mention. All right, so coming back to the point. So I was speaking about what exactly that instant and the duration. So guys, when it comes to the instant, that will happen at that particular time. So that is what I will call it as an instant. Instantly, it happened. So you'll be saying that, right? So you need to remember that. That is what we call it as a instant. But when it comes to the duration, what exactly this duration is all about? So duration in the sense, I started this session by 10 o'clock, but I continued this session till 10:30. 10 to 10:30 is the duration. So hope you understood. So you will have some period of time. So that is what we call it as a duration. This is what you need to remember with respect to the time when I'm speaking about the construct called location. All right. So hope you got the fair idea about the location. So we have two important points that we discussed about time and position. Right. Moving forward to the next important points. So this is going to be a very important question with respect to this chapter. What exactly that I have here? Guys, I need to discuss some of the ground rules with respect to the threads and the process. Is it process, sir? Where exactly this process is coming from when I have threads? Yes, it's going to be with respect to the threads as well as processor, right? So please make a note on this so don't get confused. So let's understand what exactly the ground rules that I have. So in total, I have 6 ground rules. So let me discuss that one by one with all of you. So please understand it very clearly. What is the first ground rule that I have with me with respect to the thread and processor? Listen to me carefully. Let me start with the first one. As a thread executes, they have strictly positive time duration. When the thread is being executed, so it will have a strictly positive time duration. It will not have negative time duration is what you need to remember. Actions are degenerated cases of threads. Therefore, action also have the duration. The only concept that you need to remember, thread requires a positive duration for its execution. So that's what you need to understand with respect to the first point. When it comes to the second point, in a single processor, I have only one person to do the task. The person who is doing the task is what I will call it as a processor. I have only one person, but 2 threads cannot execute simultaneously. What is that? So please understand, I have only one processor. So simultaneously, 2 threads cannot get executed. So that's what you need to understand. Sir, give me some example. We are not understanding. Imagine I have a petrol bunker. Okay, in that I have a gun. I need to pour the petrol now. So I have only one gun. So simultaneously, I cannot pour the petrol to 2 bikes. That's what you need to understand because I have only one processor. Gun here is the processor. So 2 bikes are the 2 threads. That's what you need to understand with respect to the second point. What is the third point that I have? Events have strictly positive time duration. So there I was speaking about the thread. Whenever the thread is executing, it will have a positive time duration, but I'm speaking about the events. Even event also has got the strictly positive time duration. Whenever I'm executing some event will also take some positive time duration is what you need to remember. When we consider events to be action that executes on a port device, it reduces to the first ground level is what you need to remember. So this is the first 3 ground rules that you need to understand. Moving forward to the next three, what I have. Observe carefully now. So the fourth one that I have is two input events. Please observe, two input event occurs simultaneously. So two bikes are coming, okay? So but an event cannot occur simultaneously in two processors. What is the meaning of it? The reverse way. So what exactly they are trying to say? That two input events are occurring simultaneously. Yes, two input events are occurring simultaneously, but an event cannot occur simultaneously in two processors. What is that? Two bikes are coming, okay, for a petrol. Okay, yes, they are getting the petrol, but one bike cannot get the petrol from two petrol bunks, is what you need to understand. I cannot get the job done simultaneously by two processors. So that's what you need to remember. Sir, nange time aagta ide, neevu petrol haki. No, I cannot say that. So that's what you need to remember, right? So fine, moving forward to the next point. In a single processor, two output event cannot begin simultaneously. So that's what you need to remember. Same point, whatever I had here. So I was speaking with respect to the input, but this point speaks with respect to the output, right? Moving forward to the last point that I have here for our ground rules. The thread cannot span more than one processor. That's what they say. One thread, in the sense it should get executed using the single processor. So I cannot execute one single thread in a multiple processor, is what you need to understand with this point, is what I would like to conclude with all of you with respect to the ground rules of threads and processor. Hope you all are finding it easy, right? Moving forward to the next, a very, very important part of the session. So guys, I want all of you to please make the note of these 4 points. This 4 points is going to be very, very important with respect to this chapter. So what is this 4 points that I have then? I will call this as a taxonomy of interaction. So guys, I have got 4 basic types of interactions. So when it comes to the taxonomy of interaction. So I repeat my statement, 4 basic types of interaction. So what is that 4 basic types of interaction that I have here? The first one that I have, the 2 things you need to consider. One is static. Okay, the opposite to that is dynamic. That's what you need to remember. So, but along with that, you also need to remember 2 more things, that is single processor and multiprocessor. I repeat for all of you, I have static and dynamic, single processor and multiprocessor. This is what the 4 concepts that you need to remember. So this we have stated, okay, as a different types of interactions. Let me check what are the different types of interactions that you have. My dear students, you have static interactions in a single processor system. The same way I have the static interaction with a multi-processor system in the second one. This is the 2 topics which I am going to discuss with all of you. It's going to be very simple. If you watch my session, if you read the textbook, it's going to be very difficult. That's what I would like to tell you. And the third one that I have here is dynamic interaction. Guys, dynamic interaction in a single processor and dynamic interaction with a multiprocessor is what you need to remember. So this is what I'm going to discuss with all of you one by one. Let's start. So guys, the first one that I have is a static interaction in a single processor. When I'm discussing this, so it's very important that you need to remember the 5 basic constructs. What is that? We discussed, right? Which was missing with one important one, that is location. Yes, I'm speaking about this. So please remember. So they speak about the data and they speak about the ports. Yes, what exactly they speak about the data? So what exactly they speak about the ports? Listen to me carefully. Port devices interacts in a physical way. So that's what you need to remember. I have port, right? So that is one of the basic construct. So port device interacts with a physical way, but when it comes to the data, it interacts in a logical way. So that's what you need to understand. Port in the sense it's a device, hardware device. That's what you need to remember. That's why we call it as a physical way. It interacts with a physical way. I have a device which communicates with another one. So that is going to be physical way. But data, it should be logical way. I don't have any device called data, right? So that's what you need to remember. So fine, I have example now. What is the example that they are giving? They are assuming two preposition. What is that? P and Q. So please understand, they have given 4 points. They have given 4 points and they have given some example, some diagram to understand these 4 points. Let me make it very simple for all of you. Listen to me carefully. What is the first point that they have given? They are contrary of if both cannot be true. What is the meaning of it, sir? They are contrary if both cannot be true. What is that both? Both in the sense they are speaking about P and they are speaking about Q. They are contrary. Contrary in the sense opposite. When they are opposite, when both they are not true. This is also not true. This is also not true. That's what you need to remember. So when this is also not true and this is also not true, this is contrary, opposite. So that's what you need to remember with respect to the first point. Subcontrary, if both cannot be false. What did I say here? If both are true. So please observe here, they are contrary if both cannot be true. If both cannot be true. Here, please observe subcontrary in the sense what? If both cannot be false. If both cannot be false. They are asking it to be false. If it cannot be false, then I will call that as a subcontrary. So here, both cannot be true. Here, both cannot be false. That case, I will call this as a contrary. In that case, I will call this as a subcontrary. That's what you need to remember. So what is the next point that I have? Contradictory if exactly one is true. What exactly that I have here? Contradictory if exactly one is true. Any one is true, I will call that as a contradictory. So that is the third thing that you need to understand. What is the fourth one that I have? The fourth one, please observe here. What exactly that I have here? So R is a subaltern. Observe carefully. R is a subaltern of P. So they are speaking about this R. R is a subaltern of P. When it is a subaltern of P, listen carefully, I will explain. Yes, R is a subaltern of P. If the truth of P, whatever I have here, if the truth of P is guaranteed by R, whatever I have here, if the truth of P is guaranteed by R, only then I will call this as a subaltern. This is what you need to remember with respect to the static interaction single processor. Moving forward, I have some more points. Guys, what exactly that I have here? So I have some of the examples with respect to the static interaction with respect to the single processor. So they say that static interaction in the single processor are exactly comparable to the combinational circuit. Combinational circuit in the sense I take the different units and I combine everything. So that I will call it as a combinational circuit. So static interaction with a single processor is also compared to the combinational circuit is what you need to remember. So fine. This can also be represented beautifully with the help of the things which we have already studied. What is that? Decision tables and unmarked event-driven Petri nets. I will be speaking about this Petri nets. The mosquito net matra gottirodu, Petri net gottilla namge. I will be speaking about this Petri net in the coming sessions. Using this decision table and this Petri net, I will also be able to represent it very beautifully. What is that you're trying to represent, sir? So I will also be able to represent this static interaction with a single processor. That's what you need to remember, right? So that is the first point, and they have given a beautiful example with respect to the telephone system. What is the example that they are giving? So they are considering two important things. One is unlisted number, okay? Another one is call display. Unlisted number in the sense I have not stored the number in my phone. That's what I will call it as unlisted number. Okay, so that's what they are trying to take to give the example of contraries. Okay, so one good logical conflict is that. So they are speaking about the logical conflict with respect to the call display and unlisted number. Okay, that they are saying it as a contrary. Obviously, it is a contrary. Okay, so let's check how. Both cannot be satisfied. Obviously, I cannot satisfy both. One is unlisted and call display. When I am not saved, how can you expect that the call information or the caller information to be displayed? No, and both could be waived. So that's what you need to remember. Yes, sir. You need to observe this. A conflict occurs. We are speaking mainly about the conflicts. That's a first point that you need to think. When the conflict occurs, when a party with an unlisted directory number makes a call to a party with a calling party identification. So this is what happens. When exactly the conflict occurs, I will read this slowly once again. Listen to me carefully. We are getting a conflict. So when are we getting the conflict? So a conflict occurs when a party with an unlisted directories. I'm speaking about the unlisted directory number. In my directory, so there is no, I don't have that number at all. So he is trying to call. So makes a call to a party with a calling party identification. So that's what you need to remember. I have not saved, but I'm getting that information. So how it is possible? It's a conflict, right? So that's a problem, right? That's an error, right? That's what you need to remember. Moving forward to the next point that I have with respect to the static interaction with a single processor. What is that I have? This is a very beautiful example. One more scenario that we have. What exactly that we have? A call waiting service. This is a beautiful point that you need to remember. So this point is for all of you. Okay, let me not read this. Let me explain this story. What exactly that we have here? My dear students, imagine I have a company and I will purchase a special line by paying extra charges to my company. That is going to be a separate channel. What is that separate channel? What do you call that as a separate channel? I will call that channel as a data channel. So I will purchase that channel to send my data, only the data. So fine, you all know that if I'm calling, okay, I have a special service. If I'm calling and if you try calling me, so you will get a busy tone. Correct? Yes, correct. So what happens here? This is the point that you need to remember. So what happens here? I have taken the data line. Okay, I have taken the data line. I am trying to transmit the binary bits in the data line. Okay, so don't get confused since I am using the word called binary bits. Let me conclude by saying that I am trying to transmit the data in the data line. So fine. When you are transmitting the data line, the line is occupied and you are trying to call that line using that line. So you will get a busy tone. Yes or no? Yes, because the channel has been utilized already. It is occupied already by sending the data. So at that time, what happens? That data will get overimposed with this busy tone. So my data is getting corrupted now. So how do I solve this problem? So to solve this problem, I have a conflict, right? So the data is being transmitted and then again you have a special service that, call waiting will come and that will get imposed with your data. Solve this problem. Before I transmit my data, I will disable that service. So this is what the second example that I have here for all of you with respect to the static interaction in a single processor. Only one task at a time is what you need to remember when it comes to the single processor, especially with the static interaction, right? Moving forward to the next one that I have, the static interaction in the multiprocessor. When it comes to this topic, let me give you one example. Again, we have a concept called deadlock in the operating system. Hope you have seen that. Hope you have studied that. The same concept even here also it reflects. What exactly is that? They have given Alice is trying to call Bob. Please understand this. Alice is trying to call Bob and Bob is trying to call Charlene. And Charlene is trying to call Alice. There is a loop. How do we break this loop? How do we break this loop? Let me make it very simple. You have the pen and I have the duster and I want the pen and you want the duster. So what I will do now, until you give me what you have with you, so I will not give you what I have with me. So both of us will be waiting. Let you give and let I give. So this is what both of us are doing. Okay, both of us are not giving. So we are in a state where we are just waiting. We are not doing anything. So this state is what we call it as a deadlock. The same thing has happened here also. So Alice is trying to call Bob. So Bob is trying to call Charlie. Charlie is trying to call Alice. So all of us are just calling. We are not receiving anybody's call. So how do we break this? So somebody else should call somebody. So that's why I have the fourth one. So please observe, Donald plays a calls. Donald places calls to break this chain. So this is going to be the next important point that you need to remember. Static interaction in a multiprocessor. So guys, this is what you need to remember with respect to this. This is a very important point. The same in both single processor and multiprocessor system. That's what you need to remember, right? More difficulty to detect in multiprocessor system is what you need to remember. The failures what you have in the multiprocessor system is very difficult to detect is what you need to remember. And the functional dependency in the database are static in nature. That's what you need to remember. Functional dependency, right? If you have studied the normalization, you will understand this clearly, right? So functional dependency are static in nature with respect to the database is what you need to remember. I will be speaking about client-server architecture in the last part of this chapter also, right? Both are a form of subalternation. So hope you remember the subalternation, right? So what is subalternation? So if the content of P is true, that is guaranteed by R, only then I will call that as a subalternation. That's what you need to remember, right? So this is the last topic for the day, all right? So in the next session, I will be discussing the dynamic interaction with a single processor as well as a multiprocessor. So by second session. So by saying this, I will sign off with the session. Thank you. Bye-bye. Take care.